Okay, let's go ahead and begin by checking over our do now. Several problems over here to check today. So looking at the first one, we should have gone ahead and submitted here. We've got two negative values. So again, quick sketch of the arrow diagram to kind of just get this going here. We have a negative plus a negative. So we're going to end up with a negative answer. We're going to rule out answer choices B and C. I need to, since the arrows are in the same direction, that proves to me that we need to add them together. We're just combining the arrows to get us one long resultant arrow. So looking at this, I'm going to have 32.5 plus 15.0, 574. This is going to give me 47.5, and again, we're way out here in the negative space, so this is going to be negative 47.5. Looking at our second one, we have a negative plus a positive, so the quick sketch of the arrow diagram, we're going to have a negative value, and this is 2 1/3 coming back, so that's not enough, so that's going to keep us in the negative space. So I can rule out answer choice C here. We're going to be cutting into each other, so this means that we're going to be looking at subtraction here. So I need to go ahead and start by changing these to improper fractions and converting them to have the same denominator. So this is going to be 23 over 5 plus 7 over 3, except right now we're thinking about this as being a subtraction. So we'll get to that here in a second. We still have to get common denominators here. This is going to give me 69 over 15 and 35 over 15. Again, opposite signs, so we're actually going to go ahead and subtract these absolute values. And that's going to give me 69 minus 35 is going to give me 34. Again, keeping an eye on our arrow diagram up here, we're going to end up with a negative answer, negative 34 over 15. That converts to negative 2 and 4/15. Alright, looking here at this one's pretty simple and straightforward. We have a negative plus a negative, so this is kind of like this problem over here, except it's just 32 and 15 instead of 32.5. So again, just a quick check on the arrow diagram. Should be two arrows going in the negative direction, giving me a negative answer. We're combining those arrows together to get the long resultant arrow, so we're going to get negative 47. So looking at this here, same idea. We have a negative and a positive. We have a negative value, and we have a positive value coming back, but it's not going to be enough to get us back into positives because we're way more negative here. So we're going to end up subtracting those values because the arrows are cutting into each other. And it's going to give me negative 14. Alright, which value represents the idea of having $20 and then taking away $5? So we see the word take away here. That's a keyword that we know means subtraction. So we're taking away $5. And so we go from 20 down to 15. 20 minus 5. And finally, which expression is equivalent to 40 minus 3? So we know that this would be equal to 37. And if we think about it, when we think about our arrow diagrams, if we have 40 minus 3, that would be the same thing as having a 40 and then backtracking negative 3. So this same idea is taking away. So this is answer choice C. This is actually the beginning of our lesson for today. It's thinking about this idea that there's an equivalent way to write subtractions. And here we can see that the equivalent way would be make it 40 plus negative 3. So let's go ahead and flip on over. Let's go ahead and write down our aim for today. Today's aim, Kipsters will be able to create a rule to rewrite subtractions as additions. So we're going to be talking about kind of what we just said, looking at ways we can rewrite subtractions as additions, mainly because when we think about working with positive and negative numbers, we're able to easily represent those on a number line, and we're able to easily write the rules, and use the rules to go ahead and do that work. So we're going to start here with this set here. It says, what is the sum of all of the cards above? So here I'm just going to kind of think about this out loud. Go ahead and determine for yourself what all the sum of the cards is, and then tell me how you went about finding the sum. So when I think about this, there's really kind of two ways to do it. First of all, we can think about the sum and just kind of as we go down going down a number line, the sum. So we have 9 plus 3, that would give me 12, plus negative 4 would give me, it's going backwards 4, so 8, plus negative 3, that'd be backwards 3, which would give me 5, and plus 5 would give me 10, plus 8 would give me 18, plus negative 2 would give me 16, plus 7 would give me 23. So that's one way that we can do it. And that's kind of just thinking about it step by step, one addition by one addition. Alternatively, we can also think about this as like we can combine all of the positive values, 9, 3, 5, 8, and 7. And that would give me a total of 12, 17, 25, and 32. And if I combine all of the negatives, negative 4, negative 3, negative 2, put those all together, that's going to give me negative 9. Then I can do the single addition of a positive and a negative, and that would also give me 23. So there's really two ways we can go about doing this. You kind of just have to choose the method that works best for you. So you might have said in your method that you went about adding them one at a time, or you could have said that you combined all of the positives and combined all the negatives and then added. So this is asking us what would be happening if we started to discard the cards. So our current total as we start is 23. And we're going to work from left to right. And so we're going to start by discarding or getting rid of 9, which means our new total after we get rid of that card is going to be the sum of all of these. So there's a couple different ways we can think about it. We can describe what happens. We took away, or we decreased the value by 9. Our new total here would be 14. And again, we can think about that as we took away 9. And writing that as an equation, you could write that down as 23 minus 9. Alright, so our new total, or our current total, is now 14 because we have gotten rid of this card. We're now going to discard one more card. We're going to discard the 3. So if we're taking away a 3, that's going to leave us with 11, and we decreased the value by 3. So that's going to give me 14 minus 3 is equal to 11. So again, this was an equation, so I'm going to go ahead and fix this. So it's an equation. And our current value is now 11. Now the next one is one where you want to be really careful here. If I take away this -4, that's the next card that we're getting rid of. We're discarding a -4. Let's go ahead and add up all of the values here. Go ahead and re-add all of these 5 values. Well, I'll go about it doing it. I'll add all the positives. This is 5, 8, and 7. So that's going to give me a total of 20 in the positive, plus -3, and -2, plus -5. And that's going to give me 15. And that's going to have something very strange happen to us. When we look over here, our new total here is 15. And it looks like we actually increased the value by 4. And the reason that seems so strange is because we still took away that -4. So we write this as we had 11, we subtracted -4, we took away that -4, and we actually got a larger value. We increased the value by 4. Let's go ahead and put away our next card, -3. So we had 15 before. We took away this -3. Go ahead and do me a favor. Find the new value and describe what happens and write your equation all on your own. So when we go ahead and find this value, what you should find is that we end up with 18. Because after we get rid of that, we just have the 5 plus the 8 plus the 7. That's our same total of 20. And then we only have a -2 taken away from it, which gives us 18. So again, we see that we've increased the value by 3. Alright, so looking at this, our equation would be 15 take away a -3 is equal to 18. We should start to see a pattern evolve about what's happening here. What happens when we discard or take away a positive value card? And how does that change the value of our hand? So looking up, we have 2 examples of that here and here. How does that change the value of our hand? Go ahead and answer that question. So the theme that we should see is that in both of these instances, it decreases the value of the hand. Decreases the value of the hand. How does discarding a negative value card, so these 2 examples, when we got rid of negative value cards, how does that change the value of your hand? Go ahead and answer that. We should see here that this increases the value of our hand. So let's look a little bit more deeply, really quick, at those last 2 examples here. If I was just to read over here that I started with 11 and I increased my value by 4, I would probably also write this as 11 plus 4 is equal to 15. That's probably how I would write that in expression. So we again see this idea that there's an equivalent expression here for this subtraction. 15 plus 3. That increased the value by 3 is 18. And going back, if we think about what we did on our do now, we could actually have the equivalent expression here that take away 9 would be the same thing as 23 plus a negative 9, because that's going to take us backwards. And this would be 14 plus a negative 3 would be equal to 11. So we see that for each of these subtractions, there's an equivalent addition that we can be writing. So when we look over here, and we're going to talk about kind of the operations that are going on here. What operation reflects discarding or removing a card? So again, this is that idea of we're taking away a card. So initially, this definitely looks like subtraction. However, we've seen and we talked about there's kind of a different way of reflecting upon this. When we were subtracting a positive integer, what was the different way that we could describe that subtraction as a positive integer? So when we look over at these two examples, we could change that subtraction to adding a negative. And we know a negative is the opposite of a positive. What happened when we were subtracting a negative integer? So when we came over here and we were subtracting a negative integer, it became the same thing as adding a positive. So again, a positive is the opposite of a negative. So as a general rule, we can see in both instances that we are adding. Okay, subtraction is the same thing as adding. That's definitely general to this particular thing. And here we're adding a negative instead of a positive, so the opposite of a positive. Here we're adding the positive rather than a negative, and that's also the opposite. So in both instances, we're adding the opposite. And this is where we can really bear down on this idea that we've talked about this before, but we see this now very clearly, that subtraction is the same thing as adding the opposite. And we can use this over and over again to rewrite subtractions, so we can use our addition rules, thinking about things like the rules that we've come up with, adding and subtracting integers, or things like the commutative property, associative property. So this is a really powerful tool to be able to think about subtraction as adding the opposite. So when I come over here and I want to rewrite the expressions, I want to change this negative 23 minus 12 to add the opposite. So negative 23 add the opposite of positive 12, which is negative 12. Same thing down here. I have minus negative 12, so I'm going to change it to add the opposite. So that's negative 23. Add the opposite of negative 12 is positive 12. Same idea here. Subtraction, I'm going to add the opposite. So 23 minus becomes adding. The opposite of 12 is negative 12. And the last one here, add the opposite. So that's 23 plus the opposite of negative 12 is positive 12. So what we see here is when we're adding the opposite, that first value is going to stay the same. Nothing changes there. We change the subtraction to the addition, and then switch the sign or get the opposite of the second value that we're subtracting. And that's really how it works, and it's pretty simple. Let's flip on over and look at our partner work really quickly before you get started. Okay, let's just look at the first example on the partner work together before you finish the rest on your own. So it says to rewrite each expression as a subtraction and find the value. It looks like this should say rewrite this as an addition, so it looks like my copy is a little bit flawed here. Alright, So we're going to rewrite this as an addition. So we're going to do exactly using that idea that we have before. Here I've got minus 12, so I'm going to change this to add the opposite, negative 12 or negative 8, plus add the opposite is negative 12. Alright, now we're just going to step through the process. It's almost like this doesn't matter anymore. We rewrote this as an addition so we could use the rules and the ideas that we've thought about. So this is negative 8 plus negative 12, thinking about this on a number line, negative 8 and negative 12. Tells me my answer is definitely going to be negative. And I'm going to be adding the absolute values here because both my arrows are going in the same direction, so that's using that same rule that we talked about before. And so our value is going to be 20 because 8 plus 12 is 20, and it's in the negative direction, so we're going to get negative 20. And that's all I really want you to do. Rewrite it as an addition so you can go ahead and use your rules for subtraction. Sorry, use your rules that we learned about yesterday as addition. Go ahead and finish the rest of this page on your own. Again, work through the entire thing and then check through, or finish one problem, check in. Finish one problem, check in. Okay, let's look at these solutions one by one. So looking at this first one here, I quickly rewrite it as adding the opposite. The opposite of 18 is negative. The opposite of negative 18 is positive 18. Negative 13 plus 18. Arrow diagram quickly shows us that we're going to end up with more positive, and we're subtracting, and we're going to get positive 5. Moving on to the next one, again, adding the opposite, so changes to add the opposite of negative 25, which is positive 25. 2 arrows going in the positive direction gives me a positive answer. After adding the values together, it gives me 50. Looking at this, again, we're going to be adding the opposite, so add the opposite of positive 12, which is negative 12. So positive 3 and negative 12 is going to end up in the negative. After subtracting, we're going to get negative 9. Alright, here, same idea. We're going to add the opposite. And so this is going to be negative 24 plus the opposite of 16, which is positive 16. Arrow diagram puts us negative plus a positive, but not enough to get back to 0. So we end up with a negative value, subtract the two values, and that's going to give me negative 8. Moving down to the next one, add the opposite, becomes negative 63 plus negative 12. 2 arrows in the negative direction gives me negative 75. Looking at this one, adding the opposite, change it to add a positive 112, so 133 plus 112, 2 positive arrows. This is something we've been doing for a long time. Quick check on my math here. This should be 245. And finally, the last one, we have 23. Add the opposite, so add a negative 122. Thinking about this, this is 2 arrows in opposite directions. Way more negative than it is positive, so we end up with negative 99. Alright, so again, really thinking through today's lesson, what we've really walked away with today is the idea that we can rewrite every subtraction as an addition by adding the opposite. And this is really important to us because then we can use our integer addition rules and our concepts about integer addition, but we can also think forward about this. This is going to allow us to use the commutative and associative property whenever we want, regardless of whether we have a subtraction, because we can just change that subtraction to an addition. So that's a thought for the future. Go ahead and move on to your independent alone time work.